The Hoover Dam is one of the most impressive engineering feats in modern history, a structure so massive and precisely designed that it appears to defy the laws of gravity. Built in the Black Canyon of the Colorado River, this colossal dam holds an immense volume of water, over 45 million gallons, without toppling under the crushing pressure. But how does it manage to stand tall against such an overwhelming force? At first glance, it seems like the sheer weight of the water would push the dam forward. The secret lies in its ingenious design, which leverages gravity and physics to work in its favor. The Hoover Dam was constructed during the Great Depression, a time of economic hardship and widespread unemployment. The project, approved by Congress in 1928 and completed in 1936, was a bold endeavor aimed at controlling the unpredictable flow of the Colorado River. The river, which runs through multiple states, also was notorious for devastating floods. The dam was not only built to regulate water supply, but also generate hydroelectric power for growing cities in the Southwest. Standing at 726 feet high, the Hoover Dam was one of the tallest in the world when completed. Its base was an astonishing 660 feet wide, tapering to just 45 feet at the top, a structural design that plays a crucial role in stability. The dam's vast reservoir, Lake Mead, is the largest man-made lake in the U.S., capable of storing up to 28.9 million acre-feet of water. This stored water is crucial for irrigation, municipal use, and power generation. The hydroelectric plant inside the dam houses 17 massive turbines producing about 4 billion kilowatt-hours of electricity annually, enough to power 1.3 million homes. Beyond power generation, the Hoover Dam provides a critical lifeline to the arid regions. By regulating the flow of the Colorado River, it prevents devastating floods and also ensures a consistent supply of water. It is an essential force behind the economic and environmental stability of the American Southwest. At its core, the Hoover Dam is a gravity dam, meaning it relies primarily on its own immense weight to resist the force of the water pushing against it. Unlike earthen or steel dams, which use materials that flex or absorb pressure, a gravity dam is built from solid concrete and depends on sheer mass to stay in place. The downward pull of gravity anchors the structure, preventing the overwhelming force of the Colorado River from toppling it over. In the case of the Hoover Dam, the weight of the concrete, approximately 6.6 million tons, is enough to counteract the water pressure, allowing the dam to remain stable. However, the Hoover Dam isn't just an ordinary dam. It's an arch gravity dam, a more advanced and efficient variation that combines two structural principles. Unlike a simple gravity dam, which only resists water pressure by pushing downward, the Hoover Dam also incorporates a curved arch-like shape. This means that instead of absorbing the pressure itself, the dam transfers much of the force into the surrounding rock formations, which naturally hold firm under the immense load. The distribution of force reduces stress on the dam and makes it a significantly more stable dam than a standard gravity dam of the same size. The curved design plays a crucial role in how the Hoover Dam withstands pressure. If the dam were a straight wall, the water would exert direct force against it, increasing the risk of collapse. However, because the dam is curved with the convex side facing the water, the pressure gets spread outward, forcing the water against the canyon walls. This arch effect is the same principle used in bridges and dome structures, where curved shapes help distribute the weight. A simple way to visualize this is by imagining two walls, one straight and one curved. If you lean against a straight wall, all the pressure you apply is absorbed by that single surface. But if you lean against a curved wall, the force gets redirected outward, making it more difficult to push through. This is exactly what happens with the Hoover Dam. The force of the river is not absorbed entirely by the dam, but instead redirected to the canyon walls. This design allows the dam to stand firm, even under extreme conditions. The Hoover Dam stands as a testament to the power of physics and engineering. One of the key reasons it remains stable is its immense weight, a staggering 6.6 million tons. This sheer mass plays a crucial role in counteracting the enormous force of the water pushing against it. Without this weight, the Colorado River pressure would be enough to push a weaker structure downstream. However, because the Hoover Dam is so heavy, gravity keeps it firmly anchored in place, preventing any significant movement. Engineers had to carefully balance two opposing forces, the downward pull of gravity and the lateral force of the water. If the dam were too light, the broader pressure would push it forward. If it were too steep or top-heavy, gravity might not provide enough stability. By constructing a thick base, 660 feet wide, that gradually narrows to just 45 feet at the top, engineers ensured that the structure had a low center of gravity, making it almost impossible to tip over. This design allows the dam to effectively resist continuous pressure of the 45 million gallons of water. Another essential factor is the dam's stability is friction. The Hoover Dam isn't just sitting on the riverbed, it's firmly embedded in the canyon's solid rock foundation. The massive weight of the dam creates an incredible amount of friction between the base and bedrock, preventing it from slipping forward. The rough interlocking surfaces of the concrete and rock create a grip strong enough to resist even the most extreme pressure. To understand why the Hoover Dam's curved structure is so effective at resisting force, consider a simple experiment. Imagine taking a thin, flat piece of paper and trying to stand it upright. It will quickly bend or collapse under pressure. But if you curve that same piece of paper into an arch, it becomes significantly stronger and can support more weight. This is because curved shapes naturally redistribute force, reducing stress on any single point. The Hoover Dam's arch design allows the simple principle, directing water pressure into the canyon walls rather than absorbing it. The combination of weight, gravity, friction, and an arch-based physics make the Hoover Dam one of the most stable and enduring structures in the world. The Hoover Dam isn't just an engineering marvel, it's also backed with fascinating features and little-known secrets that make it more impressive. One of the most crucial contributions is hydroelectric power generation. The dam has 17 turbines that generate around 4 billion kilowatt hours of electricity every year, enough to power 1.3 million homes. This renewable energy has been a vital part of the region's power supply since completion, reducing reliance on fossil fuels while efficiently harnessing the natural force of the river. What many people don't realize is that constructing a dam wasn't just about pouring concrete into a mold. In fact, engineers had to develop a unique cooling system to prevent the massive structure from cracking. The Hoover Dam contains enough concrete to build a 2-lane highway from San Francisco to New York City. But if it had been poured all at once, the heat from the chemical reactions within the concrete curing would have caused it to crack and weaken. To solve this, workers embedded over 582 miles of steel pipes throughout the structure, pumping ice-cold water through them to speed up the cooling process. Once the concrete set, they removed the pipes and filled the spaces with more concrete, ensuring the dam remained structurally sound for generations. One of the most mind-boggling phenomena of the dam is often called the no-spill magic trick. If you try to pour water over the edge of the dam, it appears to flow upward instead of falling straight down. This strange effect isn't actually magic. It's due to the powerful updrafts caused by the wind currents in the canyon. The dam's massive curved surface and the rapid movement of air causes the wind to push lighter objects like water droplets upward instead of letting them drop. This effect has amazed visitors for decades and remains one of the most famous optical illusions created by the dam's unique design. Beyond what's visible on the surface, the Hoover Dam also hides a network of secret tunnels and passageways inside the concrete walls. These hidden corridors were originally designed for maintenance and emergency access, allowing engineers to monitor the structure from the inside. Some of these tunnels still exist today, and a few lucky visitors on special tours have been able to walk through them, witnessing firsthand the sheer scale of the dam from within. There are even rumors of abandoned rooms, old equipment, and historical graffiti left behind by the original workers, remnants of the thousands of men who built one of the greatest engineering feats of the 20th century. From its astonishing power output to its hidden interior, the Hoover Dam is filled with surprises that showcase human ingenuity at its finest. Whether it's the science behind its design or the optical illusions it creates, this structure continues to captivate engineers, scientists, and tourists alike. Masterclasses in engineering and physics, from its sheer weight that anchors in its place to its arch gravity design that redirects the force of the canyon walls, every aspect of the dam works together to make it one of the most stable and enduring structures ever built. By carefully balancing gravity, water pressure, and friction, engineers create a structure that seems to defy gravity while standing strong against the relentless force of the Colorado River.